Anyway, I'm about to explain my Mack truck budget by truck. So it's a Mack Anthem re-rated to 220 tonne by putting a high capacity air compressor on and storage capacity and changing the affixment of the turntable so it's both sides, the top of the chassis between the front bogie spring hangers and the rear bogie spring hangers. And then that'll be more than strong enough to haul 220 tonnes because the rest of the truck is fine. And the engine I'll use is an MP8HE, 500 horsepower, 1655 low torque to 2065 peak torque. And I'll use a 12-speed direct drive M drive, 1494 first gear and 1-to-1 direct, which is a perfect gearbox. And I'll set the engine revs at 1450 revs at cruising speed, which is a 4.6 to 1 diff ratio with standard 3230 millimeter tie diameter. So how you work that is 1450 revs direct drive, so it's still 1450 divided by diff ratio 4.6 times tie diameter 3230 millimeters times 100 equals the road speed you're doing, which is roughly 100 kilometers an hour at 1450 revs with a 4.6 to 1 diff ratio. Now, what gives the extra power is these Dana Spicer double reduction tandem or tridem differentials. That's the only option. Everything else is a standard Mack truck, but this I want to install on the Mack Anthem and so on, because what it is a standard diff with hub reduction torque multipliers, planetary gear set on the hubs. So how I think it works, correct me if I'm wrong, Mack and everybody. All right, the standard diff, just a single phase diff, just crown on pinion diff without hub reduction, equals at 1450 revs with 1-to-1 top gear direct drive with a 4.6 to 1 diff and 3230 millimeter tire diameter at 450 revs, you'll be doing 100 kilometers an hour or near enough to it. Now, with the hub reduction, just say the hub reduction is a 3-to-1 reduction in the hub, which means the axle is the actual axle slides in like a dozer, and it's actually a sun gear, and then you have like say 3 planetary gears and linked to the sun gear, and then that drives the ring gear, which is the wheel hub. Now just say it's 3-to-1 in the wheel hub, the reduction in the planetary gear set. I think that you work out your standard diff ratio, which is 4.6 to 1, which does 100 kilometers an hour at 450 revs direct drive. And then you go to the wheel hub, which is just say, for example, is 3-to-1 reduction from the axle to the hub, the axle, the sun gear through the planetary gears to the ring gear, which is the hub when it revolves around. So in other words, the axle revolves around 3 times to turn the wheel once. So in knowing that, I would say you go from the center of the sun gear, the actual axle, to the outside of the hub, the ring gear, and you divide that from what that equals from the outside of the hub to the outside of the wheel, one side. All right, I'll repeat it. So from the center of the sun gear axle to the outside, one side of the hub, wheel hub, what that equals, you divide that into the distance between the outside of the wheel hub to one side of the top of the tire. All right, just say it equals 37%. All right, computer says 37%. So it equals 37%. So in other words, if that from the center of the sun gear axle, wheel axle, on a planetary reduction hub, wheel hub, from the center of the Sun Gear planetary wheel hub axle, which is the axle that goes into the diff also, from the center of that to the outside of the wheel hub, that distance, right, what it equals, divided into from the outside of the wheel hub to the outside diameter of the tyre, one side of the tyre, one half of the tyre, and it equals 36%, computer said, all right. So I believe, because that's a reduction, that means I believe what you should do is you should take 36% off this 4.6 to 1 diff ratio, which will be, say, for example, I don't know, 36% would be like 3.3 to 1, for example, or something. And then the truck would go the same speed as if it didn't have the hub reduction planetary gear sets, right, 1450 revs, with now say a 3 to 1 diff and 100 kilometers an hour. But now what you got is you got 3.3 in actual main diff times 3.3 in the wheel hub, which is a reduction of 9.9, because that's how it really works. So that's what I think. So you can correct me if I'm wrong, but because anyway, so they're not going to have a wheel hub reduction there, which is subtract from the primary reduction, the actual diff, and then it equals the same reduction, because what's the point of it? It's not achieving anything. So I believe that's how it really works. So anyway, so they should be able to allow you to calculate the actual what diff you need. All you just calculate is the center diff once you find out what the wheel hub reduction is. So, for example, you want to do 1450 revs at 100 kilometers an hour, so you have 1450 divided by your diff ratio times your tyre diameter, 3230 millimeters times 100 equals. That's for a direct drive gearbox. If it's overdrive, which is 20% overdrive, which is 078 overdrive in a Mac, minus 100, so 78% minus 100, that's 22% overdrive. So you go 1450 plus 22% equals, then remember what it equals, erase, and then put down what it equaled, divided by diff ratio times 3230 times 100 equals what diff ratio you need. So you have you have to throw different diff ratios at it to juggle till the road speed adds up to what you want to do with a particular diff ratio at them engine revs, so with an overdrive transmission. So that's how you work it all out, so it's easy. So there you go. What do you think, Mac?